Hey everyone, welcome back. I hope you're all doing great. Today, we've got an exciting lineup for you as we dive into some key features of Palo Alto firewalls. We'll be discussing zone protection profiles, virtual routers, management profiles, and interface types. Let's start with zone protection profile. A zone protection profile is a set of security measures that you can apply to network zones in your Palo Alto firewall. It helps to protect your network from various types of attacks, including denial-of-service attacks, by providing an additional layer of security. Zone protection profiles offer protection against various threats, including SANE flood attacks, UDP flood attacks, ICMP flood attacks. Let's create a zone protection profile and attach to the zone. To create a zone protection profile, navigate to the Network tab at the top and click on Zone Protection Profiles. In the New Profile window, give your profile a meaningful name and description. Here you will see multiple tabs for different types of attacks. Let's discuss one by one. Flood protection. Flood protection helps mitigate attacks that overwhelm your network with traffic, such as SANE floods, UDP floods, or ICMP floods. This protection works by rate limiting the incoming traffic. If traffic exceeds predefined thresholds, the firewall can block the traffic or drop excessive packets to prevent network congestion. Reconnaissance protection. Reconnaissance protection is a crucial feature that defends your network from network reconnaissance attacks, such as port scanning and other methods used by attackers to map your network. By detecting and blocking these scanning activities, the firewall can block attempts to gather information about your network before an attack is launched. Reconnaissance protection identifies patterns that resemble port scans or abnormal traffic. For example, if someone is trying to probe multiple ports on a system quickly, the firewall will identify this as a scanning attempt and block it before the attacker can gain useful information about your network. Packet-based attack protection helps protect against attacks that specifically target the structure and behavior of network packets, such as malformed or overly large packets that could exploit vulnerabilities in your firewall or network infrastructure. Protocol protection is used to protect your network from attacks that exploit the characteristics of certain network protocols, such as TCP, UDP, and ICMP. By applying protocol protections, you can control how traffic is handled for these protocols and prevent malicious activities like flooding, scanning, and exploitation of protocol weaknesses. Ethernet SGT protection is an advanced security feature in Palo Alto Networks firewalls, specifically within the zone protection profile. It is designed to protect network traffic that uses security group tags, a tagging mechanism commonly used in Cisco TrustSec environments. Palo Alto Networks Firewall's SGT protection ensures that traffic with invalid or tampered SGTs is flagged and blocked. This is crucial in environments where TrustSec is used to manage access control and segmentation across large enterprise networks. Once you've configured the settings, navigate to the Network tab, select the zone you want to apply this profile to, and assign the newly created Zone Protection Profile. Finally, click the Commit button to apply the configuration changes and activate the Zone Protection Profile for the selected zone. Let's now talk about Interface Management Profile. The Interface Management Profile lets you control which management services can be accessed through a specific network interface. For instance, if you have a dedicated management interface, you might want to allow HTTPS access for management purposes, but block everything else. For example, if you want to allow only HTTPS access on the management interface, you can ensure that no unnecessary services are exposed to the internet or your internal network. Now, let's walk through the process of creating and mapping an interface management profile to an interface. To create a new management profile, navigate to Interface Management under Network Profiles section. Click Add to create a new profile. In the dialog that pops up, name your profile, something descriptive like management_access or ping only. Here I am creating a profile that allows users to ping the interface IP address from a trusted network. So I have given the name ping only for the profile. Under the Services section, you'll see a list of available services that you can enable or disable, such as HTTP, HTTPS, SSA, and more. Choose the services that you want to allow. Here I am selecting only ping since I just want to allow ping. By default, Firewall allow all IPs to access management services, but you can specify the list of IP addresses, subnets, or IP address ranges that are allowed to access the management services. Any IP address not in this list will be blocked from accessing the Firewall management services. Once you've configured the services, click OK to save the profile. Now let's map this newly created profile to the inside interface so that trusted zone users will able to ping the inside interface. In the Interface Configuration page, find the Advanced tab. Here, you'll see the Management Profile field. Meanwhile, I am starting ping for the interface IP with Windows CMD so that we can see how Management Profile works after applying on interface. Here you can see that I am unable to ping interface IP. Let's apply the policy on interface and see. Click on the drop-down under Management Profile and select the profile you just created. After that, click OK to apply the profile to this interface. Now commit the changes. And that's it. I have successfully created and assigned a management profile to an interface, and I am also able to ping the interface IP now. Now let's discuss about Palo Alto interface types. Today, we'll explore 5 key interface types: TAP, HA, Virtual Wire, Layer 2, and Layer 3 interfaces. A TAP interface is used for monitoring purposes. It allows the firewall to passively capture traffic flowing between 2 network devices without altering or affecting that traffic. Think of it like a listening device. The firewall simply observes the traffic. This is especially useful for gathering security intelligence and traffic analysis without interrupting the flow. A TAP interface is typically used in environments where you need to monitor traffic but don't want to actively inspect or modify it. Next, we have the HA interface, used in a high availability configuration. When you deploy 2 Palo Alto firewalls in HA mode, the HA interface connects the devices and facilitates synchronization of configuration and session information. The HA interface ensures that in the event of a failure on one unit, the other unit takes over seamlessly, maintaining the integrity and uptime of your network security. It's the backbone of failover systems, making sure you stay protected even when one device goes down. Moving on to the Virtual Wire interface. This interface is unique because it doesn't require any IP addressing and operates transparently between 2 networks. It essentially bridges 2 network segments together without modifying traffic in the process. In this mode, the firewall functions like a transparent bridge. Traffic from one network passes through the firewall to the other without any changes in addressing. It's great for situations where you need to secure traffic between 2 networks but don't want to reconfigure their IPs. A Layer 2 interface operates at the data link layer, meaning it deals with MAC addresses rather than IP addresses. It's similar to the concept of a traditional switch port. Layer 2 interfaces are commonly used in situations where the firewall needs to inspect traffic in a network without altering the IP addressing. These interfaces can be used for segmentation or enforcing security policies between VLANs. Finally, we have the Layer 3 interface, which operates at the network layer and handles IP addressing. A Layer 3 interface is used when you want the firewall to route traffic between different IP subnets. This is the most common interface type for routing. It assigns an IP address to the interface, enabling routing between networks. Layer 3 interfaces are essential for firewall rules based on IP addressed and routing functionality. Finally, let's discuss virtual routers in Palo Alto Networks firewalls. Virtual routers are a key feature in managing traffic flow and routing between different networks. They allow you to create independent routing tables within a single firewall, offering flexibility and scalability in your network design. A virtual router in Palo Alto is essentially a software-based router that allows the firewall to manage routing independently for different segments of your network. Each virtual router can maintain its own routing table, so you can separate routing functions for different network segments or services. Every Palo Alto firewall comes with a default virtual router, which is automatically configured when you first deploy the device. This default router is used for general routing tasks, such as routing between interfaces that are not explicitly assigned to other virtual routers. Now, let's walk through the process of configuring a static route in the default virtual router. Static routes are manually defined routes that tell the firewall how to reach specific networks. Here's how to do it. First, go to the Network tab and under Virtual Routers, select the default virtual router. This is where you'll configure your static routes. Click on Static Routes, then click on Add to create a new route. This is where you'll enter the destination network and the next hop. Here, you'll need to enter the destination network, which could be a subnet or an IP range. Then, specify the next hop IP address. This is the IP address of the device that the traffic will go to next. Finally, select the interface from which the traffic will leave the firewall. For example, we are adding a static route to reach the 192.1680024th network using the next hop IP address of 192.168.126.1 via the Ethernet 1/1 interface. After filling in the necessary information, click OK to save the route, and then commit the changes to apply them to the firewall. Once committed, the new static route will be added to the routing table of the default virtual router, and the firewall will now be able to route traffic according to the configuration. To verify that the static route is working correctly, you can go to the Routing Monitor tab to view the routing table and confirm that your static route is listed. That wraps up today's chapter. We've covered a lot of ground, including zone protection profile, management profile, interface types, and virtual routers. In the next chapter, we'll be diving into NAT, or Network Address Translation. This is a crucial topic for managing how traffic flows between internal and external networks while maintaining security and privacy. You won't want to miss it. Stay tuned and make sure to hit that subscribe button so you don't miss any of our upcoming lessons. Thanks for joining us, and as always, stay secure.